Hi, this is Kevin Shryock giving you your video reply for the physics question that you submitted. So you were asking me a question about circuits, and the question was given to find the total resistance and the total current of a circuit, and this is the information we're being provided with. Now, a couple of things to recognize is that we have resistors that are in parallel, right? Parallel is whenever we have a branch in the circuit, a branch being around, here we go, let's use orange. A branch would be here and here, where essentially is going to separate and then it's going to reconnect. This is called a parallel circuit. This over here would be another parallel circuit, or parallel resistor orientation. Great. And then if we were to simplify that, it's going to come down to something along the shape of, well, we've got our batteries still. Those can be combined into one resistor. The second set can be combined into another resistor, and there's no other resistors in the circuit, so that can all be simplified where we have something like, maybe we'll call this R total 1, and we'll call this R total 2. Now, that's going to be the first step. We could take this and that's going to be the first thing we're going to simplify it to. We'll get to the math in a second. But the second idea is that we can then combine things that are in series. So series would be this resistor and this resistor, and they're going to simplify together to become, we've got our battery. They're going to squish together into one equivalent resistor. So what do we want to call this one? Maybe we'll call this one just R total. Okay, so we're going to get to the math. Let's figure out how we're going to label everything so we keep everything nice and organized. Looks like this is going to be already labeled as A, so in my math I'm going to call this resistor A, and I'm going to call this one resistor B. This is going to be resistor C and resistor D. So what does the math look like? Well, if we first want to look at the parallel configuration and squish it together to get R total 1, then let's start to write that. I'll use blue and recognize the parallel resistors have a relationship where the total resistance, R total 1, can be written as 1 over R total 1 is the sum of the inverses. Inverses just means 1 over for each of these. So we got resistor A and then plus 1 over resistor B. I can rewrite that with the numbers that it gives me, and I could say 1 over 30 plus 1 over 30. That equals out to 2 over 30, right? It's already a common denominator. And I can simplify that now by dividing the top and the bottom by 2, which would get me 1 over 15. So that is what is equal to 1 over R total 1. So if we write this all down, I've got 1 over R total 1 is equal to 1 over 15. That must mean that R total 1 is equal to 15 ohms. Alright, so we've got some information, we're making progress. Let's go on to the next set. The next set's going to follow the exact same structure. So I'm going to say, okay, 1 over R total 2. Let's use a different color. Maybe green. There we go. So 1 over R total 2 is equal to 1 over resistor. In this case, it's resistor C, right? Resistor C is going to be in that second group. So resistor C plus 1 over resistor D equals to 1 over, what are my numbers? My numbers are 80 and 40, so 80 plus 1 over 40, 40, there we go. Common denominators is going to get me both of them being over 80, so it's going to turn into what, 3 over 80? If you want to just plug it in your calculator, you can check it from there, but that is going to give me something around the lines of, let's see, 3 over 80. 0.0375. Now this is not our resistor 2, right? We have to remember back to the original part of the equation. This is 1 over resistor 2. So 1 over resistor 2, resistor total 2, is equal to 0.0375. That means that I have to flip it over and say that resistor total 2 is equal to 0.0375 inverted to the -1 power. So if I take all that and I invert it, I get something around the lines of 26.67 ohms. And that looks more reasonable to me, so I'm feeling good. So I've got my resistor total 1 is up here in the blue, my resistor total 2. So I am now officially in this picture here. So here we go. This one we said was going to be, well, this one is going to be equal to 15. Oh, excuse me. This one is going to be equal to 15. And resistor total 2 we said was going to be about 26.6. So let me erase that and write that in. About 26 point, round up, say 7. Okay, great. How do I get to the total resistance? Well, the total resistance is now taking these two, RT1 and RT2, and recognizing they are in series. So how does series resistance work? Well, series resistance works where I just add them together. So I can now, let's use purple. I can now say that the total resistance, R total, is equal to the R total 1, plus R total 2, which is equal to 15 plus 26.7, which would give me something around 41.7 ohms. And that would be my equivalent resistance. My total resistance, sometimes your teacher may write it as R sub E. Always good to match the teacher's notation because the teacher is going to be the one giving you points on the test and homework. And so there we go. This is going to be my total resistance. 41.7. Yep, checks out against my note sheet here. So is that all that the question asks? The question asks, what are the total resistance and the total current of the circuit? Well, I'm already at 41.67 is my total resistance. So that looks like it's going to put me right in with D. D is the only one that gives me something around 41.67 ohms. But it's got this 5.5 amps. And just to be sure, because I want to make sure that we're putting down the right answer and we want to double check our math whenever we can, let's go ahead and find out the current. So if this was the resistance, 41.7, how would we find out the current? Well, we'd find out the current using Ohm's law. Ohm's law states that the voltage over the whole circuit must be equal to the equivalent resistance, or the equivalent current, excuse me, times the equivalent resistance. And our equivalent resistance, we already calculated, was going to be 41.7. So the only thing I don't know is my current. So let's rewrite this as V over R equals I. That's by multiplying or dividing both sides by R. And then I would say what? That's equal to my total voltage is 230 volts. So 230 volts divided by my equivalent resistance of 41.7 ohms. And that's going to bring us out to about 5.5 amps of equivalent current. And I can box that up just nicely. And so there we go. Let's go back and see if that was our answer. Yep, 5.5 amps, because it was asking us for the total resistance and total current of the circuit. The total current is going to be what's flowing through, not each individual branch, but what's flowing out of the battery and back into the battery as the total. So if we draw that in, this is going to be just about, oh, I want a box, I want a line. There we go. This is going to be where my total current is going, right here. And this is going to be the same current going back. All right, I hope that helps. Let me zoom out so you have the final capture. We were able to get that the Total resistance was 41.7. Our total amperage was 5.5 amps. And that was able to get us to answer D. Box this up and call it good. Alright, there you have it. Hope you enjoy.